One machine essential in these drives was the shield. The shield used in tunneling not only protects, it performs other functions as well. Ungainly and awkward out of ground, once in the drive, the shield comes into its own. Soft ground tunnels are lined with segments of iron or precast concrete. Because of their weight, these linings need machine placement. This is handled by equipment on the rear of the shield. The segments, in this case precast concrete, are maneuvered under the erector and a retaining pin secured. They're then rotated round the tunnel and placed. A certain amount of juggling is required to position the segment precisely. Then bolts are driven, holding everything together. Curved bolts are added for longitudinal support, all being torqued up prior to the next step, which is the shove. Hydraulic rams at the rear of the shield push against the linings, moving the whole shield forward onto the front rams, which retract while continuing to support the tunnel face. When there's sufficient space for the next set of linings, the shove is complete. The digging arm on the front of the shield is now brought into operation, cutting soil away from the tunnel face. One shield was fitted with an Archimedes screw, a novel way of moving soil onto the conveyor system. Lasers were used extensively, and with this sort of equipment, it was possible to achieve accurate alignment over long sections of the drives. For every kilometre of tunnel driven, 8,000 segmental linings had to be transported through the airlocks, and 25,000 cubic metres of soil and rock taken from the face out through the airlocks on its journey up to daylight. As the concourses deepened, bedrock was eventually reached, and different tools became necessary. Drilling into Hong Kong's hard granite became a tedious business, slowing excavation work considerably. Many tons of high explosive were needed to break up the rock at lower levels. Charge placement is critical when blasting around the supporting columns. Although the rock has to be broken up, the column must not be damaged. Within 2 years from the start of the project, some of the station concourses had reached design depth. Causeway Bay Concourse, located 30 metres below ground, was about to be connected to its station tunnels. Breakthroughs were always a special occasion, with celebrations in order. Moments like these gave the construction crew a chance to lay aside, temporarily at least, the anxieties and responsibilities of the project. But work in the tunnels was far from complete. Where soil conditions were firm, shields were dispensed with and the face cut back in steps, thereby minimizing the risk of disturbing ground pressures and possible collapse. A modified version of the new Austrian tunneling method was sometimes used. Here, steel arch ribs and mesh were used to support the tunnel walls in preparation for a coating of shotcrete to prevent the soil loosening. This technique was suitable mainly in compressed air, as without it the ground could dewater and the tunnel cave in. Once the shotcreting was complete, shuttering could be placed and the permanent lining cast. Compressed air workers, finishing their shift, were faced with half as long again in the airlocks, ridding themselves of accumulated nitrogen.